can, yeah, we can wait for 5 minutes. Okay. So then we'll start the session.
Okay.
Right. So, guys, I think hope I'm audible to everyone. Please
Yes.
confirm. Yeah.
Yeah.
Right. So, good evening, everyone. So, let me introduce myself. Uh, this is Krishna, and I'm having almost close to 17 years experience in Java and Jdbc platforms. And from 2007, I started my career along with this training uh, on the Java and Jdbc, like CoreJava, Advanced Java, all these things I have been trained. Earlier, I trained in Nourish Technologies, and later I came to DURGASOFT. So, and currently I'm playing as a senior architect role in one of the MNC company. And this is what my overall experience. So whatever the course content I have shared to you, if you have not received any course content, you can collect that course content from the DurgaSoft. Okay. So, and also the notes and all, I have my own material. Uh, I will share that material to you. I will not put my enough time on this material notes, dictation and all these things. Okay. So we will more focus on the topic and along with the practical example and the real-time usage of the topic, where and how it works and all. That is how the course will go. And I will give some ample amount of time in the end of the session or in between the session. I will ask for any questions from your end. So then you can utilize that time for your questions. So in that way, we can continue our discussion. Okay, so that is what the point. So let's talk about the course today. What is the Spring Boot and microservices, right? Whenever you heard this name, Spring Boot microservices. So what is the main thing you are going to learn first of all? So in this course, Spring Boot microservices, first you need to understand what is Spring Boot exactly. You already have a Spring framework in the market. From 2006, 7, and 8, 9, during that year, 8, 9, 2009, Spring framework got more importance than EJB applications, enterprise Java beans. So that is what the main thing. Okay. So that is what overall thing, what you need to understand. So today I will introduce you why we need to go for Spring Boot. We already have the Spring framework in the market. What is an importance? So we have to understand that small introduction first. Then we'll talk about all the concepts in depth in the Spring Boot. Okay. So first we have to cover all the topics related to the Spring Boot first. Then after that, we'll talk about microservices. Of course, I will introduce microservices in the middle of the concepts of the Spring Boot. because microservice is an architecture for developing your application, web applications, right? So in the middle of the Spring Boot concepts, we are going to touch what is microservice and why we need to go for microservice, etc. Okay. And also in the middle of the course, I will show you how to deploy your applications using the Docker containers. Okay. And using the Kubernetes deployment in the cloud, like AKS, Amazon, that Kubernetes service, and as well as Azure Kubernetes service is there. AKS, sorry, Azure Kubernetes service. EKS is there. Elastic Kubernetes service from Amazon. We will show you a couple of deployments in the multiple clouds. Okay. So finally, in the end of the course, you should know how to deploy your microservice applications in the multiple clouds, how to leverage the cloud features for developing microservice application, in what type of different real-time cases. I will share my experiences in the real time at the time of developing different applications. I have an experience in the two different cases. One is converting completely monolith applications to microservice. Monolith is nothing but one kind of architecture model, legacy model. So that I transfer to microservices. The second thing is building the microservice application from the scratch level. Okay. So like that, I will tell you in what cases and how we work and all. And also who are there in my class, right? The target audience can be a real-time people. That means the people who are already working in the companies, or who want to get a job in the company, or who want to change a career to the Spring Boot and microservices. This class targets all the audiences. So my class will go in this space only. So that means the speed level. Okay, I will not go fast or I will not go slow. Depends on the concept. I will adjust my speed accordingly. So in the beginning days, like that is 3 to 4 days, the class will go something up to 1 hour for 4 days. Once the batch is settled down, we will increase the time to 1 hour 20 minutes. That is our session time. 1 hour 20 minutes is our session time. And the class will be Monday to Friday. So there is no class on Saturday and Sunday. But I will give assignments to you. So you have to do that assignments in the weekend. And you can forward that assignments in the to my mail ID. I will give that. So I will review that and I will suggest you in case if you do any mistakes, etc. Okay. So like that will follow accordingly. And also interview questions, etc. and etc. All these things are there in my material. I will share that notes also to you. All right, guys. That is about overall introduction up to now. Now let's start the session. So let me share my screen and please confirm whether my screen is visible to you.
It's visible.
Good. Okay. Right. So now let us discuss today's topic. Why Spring Boot? Okay. So Spring Boot is a framework which was developed by the Pivotal team. We can call that company as an open source community. Okay. So this Pivotal team developed the Spring framework, and the same team developed the Spring Boot also. So the Spring Boot is a framework which is developed on the top of the Spring framework. So first of all, if you already know the Spring framework well and good, if you don't know the Spring framework at all, that is also not a problem. So we'll target both people here. Okay. So Spring framework is introduced in the earlier days to address the complexity which was faced from J to E, Java to Enterprise Edition, that we call it as a EJB applications, Enterprise Java Bean applications. Simply we can say it as a middleware, or we can call it as an enterprise layer, business layer. So our most important business logic, whatever the logic we are developing, right? At the earlier days, these people uses this J2EE, that is nothing but RMI, remote method invocation, enterprise Java bean, message driven beans, right? All these things are there. That creates a lot of complexity to the programmers. That means writing the code. Whenever complexity increases in developing the code, obviously testing your application is also very difficult. Maintaining your application is also very difficult. And also it affects the cost of the application. As the maintenance increases, obviously the cost is also increases, right? So to address all these problems, Spring framework introduced in the market at that time. Okay, Spring framework is introduced. Okay, Spring framework addressed all these problems. What do you mean by addressing the problems? It eliminates the boilerplate code in your enterprise applications. That means there are multiple modules are there in the enterprise layer. For example, session bean is there, stateless bean is there, stateful bean is there. Okay, message driven bean is there, database connectivity is there, transaction management is there, logger management is there, security management is there, aspect oriented programming is there. See, any area, whatever we are talking here, from standalone application to enterprise application, any layer if you take, there is a boilerplate code. Boilerplate code means, for example, if you take an example of database, right? Generally, you people are using Jdbc, right? So what we are trying to do with Jdbc generally, first we have to use class dot for name. You have to load the driver. Then after that, you have to prepare the database connection. That is connection con is equals to driver manager dot get connection. Then after that, we have to create a statement object or prepared statement object. Then after that, you have to submit an SQL query to the database. Then you have to collect the result set, right? General story I'm talking. So majority of the boilerplate code, whatever it is there, that can be loading a driver or establishing the connection or creating the prepared statement object, whatever it may be. All these things will be handled by Spring Framework. Okay. Even though, if you take an example of EJB, Enterprise Java Bean, very legacy concept, that's it. In EJB, once again, there is a session bean that is stateless and stateful. Entity bean is there, right? So whenever we are dealing with the EJB, we have to write a huge amount of code. For very simple demo applications in the earlier days, almost I have to write 300 lines of code in EJB, a simple demo application. Think about. So that complex amount of logic is easily reduced with just 5 to 10 lines of code. If I write in my way, my job is completed. I can write the same application by using Spring Framework equivalent to my EJB or equivalent to my Jdbc or equivalent to my Servlet or equivalent to my JSP, right? So any area, whatever you touch, boilerplate code, wherever that code is there, that will be reduced. That's the beauty of Spring Framework. So I am talking till only the benefits of the Spring Framework. Then you have to ask the question, right? There is some question striking in your mind. Then you are saying, we have a very wonderful benefits in the Spring Framework, right? Then why Spring Boot is launched in the market? Why? What is the main reason? I agree with that point. Spring Framework beautifully solved all the complexity of the problems, and developer life is very easy. In the year of 2007, 2008, at that time, if you know the Spring Framework, that time, the job is a very hot cake. People got a job if they know the Spring Framework, if they have at least 2 to 3 months experience at that time. I'm talking about the year of 2007, 2008. At that time, they started migrating all the legacy systems into Spring Framework. Okay. Now, I'm talking about the year. I'm talking about the year 2017 and 2018. Once if you come into that year, 2017 and 18, industry, this IT industry applications are migrated to microservices architecture applications. Okay. Up to now, whatever we discussed using Spring Framework, we can develop only monolithic architecture based applications only. We cannot build microservice applications by using Spring Framework. Keep this point in the mind. Using Spring Framework, I can eliminate the boilerplate code from the J2EE applications. Legacy applications I can eliminate. I can increase my performance. But those applications are only for monolithic based applications. Those are not suited for microservice architecture model. Okay. Now I will tell you what is monolithic, what is microservice. I will give a quick introduction in this today's class. Then after that, you will understand what is Spring Boot. You will understand very quickly. Okay. So now let me talk about the diagram point of view. So now let's take a simple diagram. If you see here, monolithic architecture is nothing but your entire application, means the application what we developed. For example, I have an application called shopping cart application. So this shopping cart is one of the application, e-commerce application. This entire application deployed into the single server. That means packaged into single file and deployed into the server. Okay. So this is my server. Inside this server, I have hosted my application, shopping cart. So that means, don't confuse guys. When I'm talking about this application, right? Entire application means in the shopping cart, there are many functionalities are there. For example, order management, placing an order, canceling the order, okay, viewing the order, adding the items into the cart, latest available items, etc. and etc. There are many functionalities are available in the shopping cart. So all these different functionalities in your project, we can call it as multiple modules. In the earlier days, I'm talking about earlier days terminology, guys. So in the earlier days, what the people will develop means they will create a module for order management. So this is one module. Similarly, they will prepare a module for cart management. This is one more module. Similarly, they will prepare a module for payment gateway. So like that, they will create multiple modules. So all these modules packaged into a single file. All these modules are packaged into a single file. That file we can call it as a year file, right? People will call it as a year file. That we can call it as enterprise archive resources file. Okay. Enterprise archive resources file. Okay. So this enterprise archive resources file contains all these multiple modules. So each module, this order management, is packaged into WAR file. This cart management packaged into WAR file. So usually these are all web modules, web archive resources file. Like that, every module packaged into WAR file. Finally, all these WAR files are compressed into a single file called year file. And finally, this file is deployed into the server. That server can be JBoss server, WebLogic server, Glassfish server, Tomcat server, IBM WebSphere. Like that, there are many servers are available, right? So they can select the server. Okay. So this is the style of legacy deployment, monolithic architecture model. So what do you mean by monolithic architecture model? What is the definition? All the functionalities of your project that we can call as multiple modules of your project merged into a single file, and that file is deployed into the server. That we can call it as monolithic architecture model. So this is fine. Now, what are the problems facing from this monolithic market? Why suddenly market changed to different architecture? Till 2017, in that up to that period, right? 2016-17 up to that period, people are using monolith architecture only. I can see still companies are using monolith architecture up to 2018 also. Then after that, why the rapid transformation started from monolith to microservices? Why? What is the reason? Why means because of too much amount of network traffic. Too much network traffic. Yes or no? Why network traffic increases from that period? Why? Because of your smartphones. Smartphones only. The entire world is in your hand. That's why too much amount of network traffic. So what do you do with your smartphone? Generally, tell me. Many apps are there in your phone, right? That can be Amazon order system is there, Swiggy is there, Zomato is there, ticket booking apps are there. Tell me really, how many people are using Amazon app or Myntra app really placing the order? Tell me honestly. How many people are using for time pass or window shopping? I can use better word, window shopping. That means just visiting that app and seeing what are the things are available, adding them into the cart. And we will not purchase it. Right? Yes or no? So, because of these things, because of the smartphones, evaluation from the year of 2017 and 18, too much network traffic is there. At that time onwards, it is started. Before smartphones, what you people are doing earlier days, tell me. You people carry your own laptop. At that time, laptop trend is there. That means you have to connect your mobile hotspot to your laptop, and you can use the internet services in your laptop. Or you have to sit in your home to access your internet services. Or you have to go to any internet cafe to use the internet services. That is a very olden days I'm talking. So see that network traffic, guys. So the number of users who are using services. Now tell me, we have order management is there, cart management is there, payment gateway is there. Let's see, you can take these three services are there in the shopping cart. Now tell me, how many number of requests comes to order management? How many people really places the order? How many people really add the items into the cart? Or how many people really do the payment for the order. So that means the thing here is, if all these services, if all these modules are deployed into the same server, if all these modules are deployed into the same server, server load is increases. Because different requests are coming. The people who want to place an order, the people who want to add the items into the cart, or the people who want to do the payment gateway, all the requests are hitting the same server. So obviously server load is increases. Whenever server load is increases, what you people will do in the earlier days? They will go for the concept of scaling. In scaling, there are two types of scalings are there. One is vertical scaling. Another one is horizontal scaling. Vertical scaling is supported for monolithic architecture. So that means what they will do, vertical scaling means what they will do means they will create one virtual machine. They will create one virtual machine. Virtual machine is nothing but one CPU. One CPU is nothing but one virtual machine. So, allocating some amount of hardware to that virtual machine is nothing but the concept of vertical scaling. Okay. For example, 2000 requests are coming. 2000 requests are coming to this server. For every 1 minute, 2000 requests are coming. Of course, this is a very small network traffic, what I am talking now. Per minute, 2000 requests. Now, for example, to handle this load for monolithic architecture, I have created 4 different virtual machines. 4 different virtual machines. That means allocating some hardware. That means RAM configuration, hard disk configuration, everything. So one virtual machine is equals to one CPU, right? Some people will call technically as node also. Okay? So whenever I'm talking a node is nothing but it's a virtual machine. That is nothing but a CPU. Allocating some amount of hardware depends on my application requirement. Depends on my application requirement. I will allocate some hardware. I will tell to the DevOps team or to the networking team, whoever configure this hardware, I will tell them, I will give the specification. Hey, please give 64 GB RAM, 4 CPUs, 4 core CPU, or 8 core CPU, or 15 core CPU. I will tell. Okay? In that way, they will create multiple VMs. So remember, guys, creating a new virtual machine, nowadays, it is very easy because of the cloud concept. Okay. Before cloud evaluation in earlier days, where the applications are deployed in the company-owned data centers or client data center. Suppose if you are working in the company of Wipro is having its own data centers. There you can deploy. Or if you are working for any client of Wipro, let's say the client name is X, in the data center, you have to deploy. Okay. So how many number of VMs I have to create? That depends on the load of the traffic. Can you give 100% guarantee always the same load is coming? That means for every minute now I am saying 2000 requests. That is what my current load. What happens tomorrow? What happens day after tomorrow? We cannot predict, right? Load can increase or decrease. Of course, we can predict some average value, right? So how many number of VMs I have to create? That is impossible to handle the current load of the traffic. This kind of architecture model is good for limited network traffic, not fluctuated traffic. Okay. So we don't know when the load is increases and when the load is decreases. Load means the number of requests coming to your application, number of user requests. Okay. So monolithic architecture is nothing but packaging all your modules of your project into a single file, and that is deployed into the server. So that to handle the load, you have to create multiple virtual machines for deploying your application. And you have to put one load balancer to divert the traffic to the VMs. Okay, so that is how the old style of process is. So what happens if the 2000 requests came to 1000 requests or 100 users, 100 requests? At that time, there is no use of these virtual machines, right? So these virtual machines becomes idle. So you have to invest money for these VMs, right? You have to maintain licenses for the softwares or hardware upgrade in this multiple virtual machine, maintenance, all these things. So these are the problem. And what is the another problem is maintenance. Suppose, for example, I want to do some enhancements to order management. I have to do some enhancements to order management only. I don't want to touch cart management or payment gateway. Okay, I will do the changes in this order management module. What I will do? Again, I have to redeploy my application. Again, that means again I have to create a year file again, means I have to create a new file. And again, I have to deploy that file into this server, right? So what happens here? Your cart management, payment gateway, all these modules will go down. If the server come down, all these things will go down. That means maintenance is also a difficult migration, right? So to handle these things, to handle the current load of your application and all, we are going with the microservice architecture model. So what this microservice architecture model is saying, so what is difference from monolith? In microservice architecture model, everything is single. Whenever I'm talking about micro means a very unique, a single functionality. That means breaking your project into multiple services. So each service is nothing but a microservice. That means, for example, my order management is one microservice. Similarly, cart management, this is another microservice. Similarly, payment management, this is another microservice. So what do you mean by microservice exactly? Microservice is nothing but breaking your complex project into mini functionalities. Here, a functionality is nothing but a service. Order management is nothing but one service. Cart management is nothing but one service. Payment management is nothing but one service. Like that, how many number of services or how many number of functionalities are there for all these things? We are going to create multiple microservices. Say like for complex project, we have 30 to 40 microservices. Okay. Depends on the architecture model. Just I'm giving a small number. 30 to 40 microservices will be there. 30 to 40, between only people will design the architecture. 20, 30, 40. Maximum people will settle down with 20 microservices. Beyond that, they will go for the different architecture designs, whatever it may be, in microservices only. So order management, cart management, payment management, all these are different microservice architectures, right? These are the different services what we have. Now, order management runs in its own server. Similarly, this cart management service runs in its own server. Similarly, payment management runs in its own server. So server is not common for all the things. Every service runs in its own server. Okay. So what is an advantage here? Isolation, right? That means if something went wrong with order management, that will not impact on cart management or that not impact on payment management, right? Other services will work fine. Similarly, the load is distributed. That means who want to place an order, that user request will come to this service, order management. Who want to add an items or remove the items in the cart, that request will come to cart management. Who want to do the payment for the order, that request will come to payment management. So load is distributed. Earlier, all the requests come to the same server because entire thing is packaged into single, right? Monolithic. But in microservices, we are breaking into multiple services. That's why the load is distributed, right? So once the load is distributed, what happens here? We can manage our applications easily. That means if the load is increases for order management, we can apply the scaling here. Scaling means which scaling here? Horizontal scaling. We are going to go with the horizontal scaling. In microservice architecture model, we are going with horizontal scaling. So what is horizontal scaling exactly here? Horizontal scaling is nothing but it is a process of running your server into like this. If you take one VM here, one node, one virtual machine, inside this virtual machine, I can create containers. So all these are containers here. We'll talk about containers later. These are nothing but Docker containers. We can simply call it as a mini virtual machine, just for your understanding for now. So I can run my order management in this containers. The same order management service deployed into containers. So how many containers I can create in the node? That is up to that node capacity, the configuration of the node. I can increase the containers or I can destroy the containers. So that's the power of horizontal scaling. Horizontal scaling is nothing but increasing the containers. Containers are nothing but mini virtual machines inside the VM. So where we are running that service. So whenever load is increases for that service, we are going to spin up. Spin up is nothing but creating new container again and running that application in that container. Whenever load reduces, automatically your containers will be destroyed. So in that way, you can save your money. At the same time, you can handle the network traffic. At the same time, your application always available 99.9%, right? So there is no downtime for your application. So these are all the benefits. So that's why microservices are very good architecture model. Remember, the only one drawback for microservices, it demands infrastructure. That means you have to configure huge amount of infrastructure. That is one-time effort. Okay. If you invest some amount of money on this infrastructure means allocating the hardware for that virtual machine. That is one-time investment, at least for 3 to 4 years. We can manage. Not like monolithic. In monolithic, every time you have to invest the money to increase the virtual machine. Whenever if load is reduced, again you have to stop that virtual machine. These things will be there. But that is not here. So this will be handled automatically, and based on that, billing will be calculated. Okay. So we'll tell all this, we'll discuss this point more details in the Docker, that is containerization in the Kubernetes. All these things will touch in the middle of your course. We'll cover everything. Okay. And finally, this microservice architecture model is supported by your Spring Boot framework. So the Spring Boot framework is created based on the microservice architecture model. Okay. So the Spring Boot is implemented on the top of the Spring framework. So what are the benefits available in the Spring framework? All are available in the Spring Boot. Additionally, the Spring Boot is supported for microservice architecture model. Okay. And some people ask the question, can we develop monolith applications on Spring Boot? Yes, why not? We can develop monolith applications also on the Spring Boot. I will show you. Okay. Some companies are still using Spring Boot to take some advantages in monolithic, and that is not a microservice model. Nowadays, people are saying, I'm using microservice architecture, I'm using Spring Boot. So don't trust it as a pure microservice. So pure microservice means what you understand now, that is pure microservice. What is semi-microservice and all? Semi-microservice means some is some monolithic, some microservice, mixed both. That is also there in companies. I will show you with examples. You will get clarity. Okay. So that is what an overall introduction for our today's session, guys. Why Spring Boot? We understand. Okay. So if anyone asks the question, why you are learning Spring Boot means, I want to develop a microservice application. That's why I'm learning Spring Boot. That is the answer you have to tell. That is the main thing. Okay. So that is what need to understand for our today's session. And any questions, you can go ahead, please.